Here are some compound inequalities and an OR. So remember, an AND inequality is going to be shaded in between. So if you had, 2 points, it's going to be shaded in between. And an OR is going to be shaded away. Okay? So if we look at number 1, this has 3 pieces. Actually, it's 2 inequalities in one whole inequality. Do you see this? So we have this, and it's all connected. This tells you right now that this one is an AND, okay? So I know that it's going to be shaded in between. So our goal here is to get x by itself. So I'm really focusing right now on what's going on in the middle here. Okay, I want to do everything I can to get rid of this plus 4 and the times 2, so x is by itself. So we know we need to get rid of this plus 4 first. I'm going to subtract 4, but now since there's not just 2 sides here, there's actually 3 sides of the inequality. So if I subtract 4 in the middle, I also need to subtract 4 on the left side and on the right side. So on the left side, I get negative 14 is less than or equal to, the plus 4 minus 4 becomes 0, so I'm only left with 2x in the middle is less than, what is that, 8. Okay, and then the last step here, I have 2 times x. So to get rid of that, I need to divide everything by 2. And I get negative 7 is less than or equal, 2 over 2 is 1, so x is less than 4. Okay, so this is our compound inequality. All right, now we need to graph this. This is actually 2 inequalities at once. It's this one and it's this one. So the purple, the thing I circled in purple, x is less than 4. We're used to seeing something like that. But in blue, the negative 7 is less than or equal to x. We don't like that it's written that way. We want x on this side, negative 7 here. Is that x is greater than or equal to negative 7? Okay, so I know they both say less than in this big inequality, but actually one's meaning greater than, one's meaning less than. So let's graph this. If this is 0, negative 7 would be over here somewhere, 4 would be over here somewhere. So at the negative 7, it has an equal to part, so it's a closed circle. At the 4 is an open circle because it does not have an equal to part. And since we're shading to the right on negative 7, the left on 4, we want the overlap, which is the middle here. So we're going to shade in the middle. So ta-da! Now let's look at an OR. Okay, remember ORs are going to be shaded away. And we know number 2 here is an OR because it says the word OR. That gives it away, right? So this is an OR. Now this one we really just solve it like 2 separate inequalities and we just end up graphing them on the same number line. So here I'm going to multiply both sides by 2 because that gets rid of the divide by 2. So I have x minus 7 is less than or equal to negative 6. And then I add 7 to both sides. So I have x is less than or equal to 1. So that's one side of the inequality. And then I come over here and I get x by itself on this side. So I'm going to subtract 3 from both sides. Negative 2x is less than negative 10. Divide by negative 2. Now we are dividing by a negative, which is important because this less than becomes a greater than. So I have x is greater than 5. So I have x is less than or equal to negative 1 or x is greater than 5. So I said less than or equal to negative 1, positive 1. So if this is 0, here's 1, here's 5. It's a closed circle at the 1 because it has an equal to, and we shade to the left. It is an open circle at the 5 because it does not have an equal to, and we shade to the right. And that's all. Ands and ors.